Magnetic fields are produced inside coils as well. In grade 11, we would have done just the left-hand, right-hand rule, but now that we have an equation, we can get a value for it as well. Our equation for the magnetic field of a coil, B for magnetic field, is our magnetic field constant, which is the Greek letter N, multiplied by the number of loops, multiplied by the current, divided by the length of the coil. Length is on the denominator. If we could jam those coils even tighter together, that would have the effect of increasing the magnetic field. Plugging in our numbers, mu for air is always 4 pi times 10 to the negative 7. Because we've wrapped it around a nail, the metal of the nail magnifies the field constant. So instead of 4 pi times 10 to the negative 7, I'm going to put in 120 multiplied by the 4 pi times 10 to the negative 7. That's commonly how the magnetic coefficient works for these kind of problems. We're given a multiplier. If it's not air, how much to multiply it by for the material we're using. So the 4 pi times 10 to the negative 7 multiplied by 120, that takes care of the constant. It says there's 100 loops, and the current through them is 4 amps. The nail, or all these coils, are in an 8 centimeter span, so 0.8 meters goes on the denominator. Cranking that out, we get a B of 0.75, and it works out to be in teslas. When we did a long straight wire, we got a much, much smaller magnetic field. Long straight wires don't really create a strong field, but when we wrap it in a coil, especially if we put a metallic core, that amplifies the magnetic field. For the last part, we need to do a left-hand, right-hand rule. This one says, from your perspective, the negative flow is going counterclockwise. So it would be sort of a diagram like that. If we apply left-hand rule for that, again, it's hard to show left-hand rule when I'm drawing on an iPad, but it says negative flow, so left hand. We want your fingers to go clockwise. So orientate your hitchhiker hand, your left hitchhiker hand, so your fingers are curling clockwise. When you do that, your thumb is pointed towards you. So if I was drawing it, I would draw it as a dot. That's a little bit messy. In words, I would say that the vector is out of the page or towards